Direct and reverse reductions. So far, we have discussed the process of transferring the measurements at the surface of the Earth down to the surface of the ellipsoid. For example, measurements like distances at the surface of the Earth are converted to geodesic distances at the surface of the ellipsoid. If we have azimuths between the points, these azimuths will be transferred or converted to geodetic azimuth at the surface of the ellipsoid. This process is called direct reduction. Direct reduction means reducing the measured geometric quantities at the surface of the Earth to corresponding ones at the surface of the ellipsoid. So the goal of this process is positioning. For example, if we have coordinates for one point, which I am showing here, and I have the geodesic distance of this point and another point, for example, here, and also the geodetic azimuth between the points, I can determine the coordinates of this point. This means that I can generate or compute coordinates of a set of points. And also, based on those coordinates, I can generate a map. This is a direct problem. But the reverse problem is the opposite process to the direct problem. It means that if we have the geodesic distance at the surface of the ellipsoid, I convert this back to the corresponding one at the surface of the S. If I have a geodetic azimuth at the surface of the ellipsoid, I will transfer it back to the planar azimuth at the surface of the S. So all this process, which is the opposite to the direct reduction, is called reverse reduction. Converting the measured geometric quantities at the ellipsoid's surface to corresponding ones at the S surface is called reverse reduction. The goal of reverse reduction is to boundary determination and setting out. For example, we want to make a big project over country, and we need to design some boundaries of design roads, for example, and want to transfer them back from the ellipsoidal geometry that we have designed, then back to the reality or to real S. Or if we want to determine the boundary between two lands or two countries, this is done by these reverse reductions. First, the boundary is specified at the surface of the ellipsoid, and after that, we should see how this boundary is in the real world or at the surface of the S. Therefore, we have to perform all the process in the reverse form to come back to the real Earth or the Earth surface.